right. Thank you very much for having me. I am Tyler Lemburg, here to talk about the mutation game, cracking the enigma of mutation testing. Here I am. All right, so a little bit about me. I'm an engineering manager at Ideon. We're a remote Ruby company. We're kind of like the tubes that connect the health insurance and benefits industry together. So we take your information from, say, Rippling or Gusto or whatever benefits administrator you use, and we have APIs that will send that through to United Healthcare, Anthem, et cetera. So if your insurance claim gets denied, it might be my fault. I've been a, you can see there. I've been a Rubyist for 14 years. Recently, I've been getting into some native iOS and Android stuff, which has been pretty fun. I once got the top 100 on Advent of Code, and that was even without AI. Thank you. I'm from Nebraska, and like all Nebraskans, we love all Husker sports, particularly football. I don't know if you guys know this, the locals do. There's this rivalry. The locals probably outnumber me here, so I'll just skip this slide. So today I'm going to talk about what is mutation testing. I'm going to talk about the tools that you can use for it and how they work. We'll do a live demo with some examples, and I'll show some common gotchas in the process. I will talk about the benefits of the technique and why it's really good for certain code bases, and of course the limitations and caveats too, so we know that like when we don't want to use it, what the trade-offs are. And finally, I'll answer, should you use it for your Ruby or Rails code base? All right, so let's lay out exactly what mutation testing is. It's basically you test your code by altering it in silly or not so silly ways. And then you're running your unit tests on that altered code. So you have your tests over here, which you have written, and you're using automatic tools to change up your application code and see if that will actually break your tests. Ideally, it does. Ideally, your tests will now fail or raise an error because you have tested the functionality that you're changing over here. However, if your tests still pass, then there's something that's happened. Either the alteration to the code was a simplification that you can adopt and make your code simpler, or it's something more complicated where you need to have your tests cover more functionality. In other words, you wrote more code than you tested. Or lastly, sometimes the alteration that the mutation testing makes to your code really is like a silly thing that you should not have to worry about. But you're playing a little bit of a game here because you want to get that 100% mutation coverage. It's kind of like a code coverage tool, so you're making some silly change to your code or your test case to make it work. There's always this frustration that goes with it sometimes. Let's look at a quick example so I can kind of explain exactly what we have here. So on the right, you'll see some code at the top. I'm getting an X-man out of the registry. I just take in a name, attach a prefix to the string, and look in big hash for it. And down below, I have a spec. I am just testing that if I call that function with Nightcrawler, I get Kurt Wagner when I have the constant as specified there. So this is the first step in mutation testing. You must get your test cases to pass. You must have a fully functioning test suite that works. All right, so what's the next step? Now mutation testing on this code is going to change up the code. For example, in this case, and this is probably the most common case that mutation testing finds, I'm accessing this hash with the brackets operator, but I'm not checking whether I don't have that mutant in the registry. So if I'm handling nil, I need to have a test case for that. If I don't want to handle nil, then I should be replacing that with the brackets operator with fetch. So fetch is basically more specific than the brackets operator, right? Brackets operator returns nil if you don't have the key, whereas fetch will throw an error. And so that's what mutation testing is doing, is it's saying, oh, I can change that brackets operator to a .fetch, and let's see if that breaks your tests. In this case, it would not break the test because there is no test for if the key does not exist. So in this case, I probably want another test that's going to say, I didn't find the X-Men or something like that. Okay, so that's how you do it. Now, how do you really do it? What are the tools for it? Really the best and only tool for doing this in Ruby is the mutant gem. This is a gem that's been around for, I think it's been around for almost 10 years now. It uses the parser gem on the back end to parse the Ruby code into an abstract syntax tree. That's how it knows what your code is doing and how to break it down and mutate the various different parts of it. So then it's going to go through and monkey patch all of your methods with mutations of that code. So it's found all these mutations like the .fetch in the abstract syntax tree and is rewriting your code and then running tests against it. And so, for example, it actually only tests in isolation with the methods or classes that you specify. So, for example, if I have an RSpec that says describe Turing test and I run mutation testing with that, those tests are only going to be run against the mutations for that specific method in my code base. So ideally, again, the tests will then fail, and that means the mutation is killed. I like to use the word eliminated. Killed is a little final. But then, your mission for this to get 100% mutation coverage is to eliminate all the mutations by either adding more tests or removing and simplifying your code. Okay. Let's get into the obviously flawless live demo. And to do the live demo, we're going to play a little game called Benedict versus X-Men. This is, Benedict Cumberbatch, of course, from the Imitation game, which, of course, inspired the title of this talk. And we had the X-Men because they are the mutants. So we'll be talking about their box office numbers today. And let's dig into it. Oh, Heroku's spinning up here. 1 second. I know I clicked next. Yeah, flawless live demo. It's always how it goes. There we go. Okay. So the first step, I've created 2 arrays of the box office numbers for the 14 X-Men movies and for the latest 14 Benedict Cumberbatch movies. So I wrote some code just to make sure that they're the same size, and yes, they are. That's what we're looking at here. So let's do some mutation testing on that method. All right, so at the top I have a calculator class, which is just asking, are the arrays the same length? Pretty simple method, I would say. And on the far right here, I have my tests. One simple case here, I'm just checking that the arrays are the same length, and of course, I expect that test to pass to be true. All right, so to run the mutation tests, then you do the command of bundle exec mutant run. And you can specify, as you can see here, the exact method you want to run it on. So just like this, I do like that with my calc method. All right, I got a 90% coverage. Now let's look at the output of this a little bit, because that'll help us see what's going on. It's going to count up the number of possible mutations that it can do here. So it's doing 6 different mutations. In other words, it's running the tests for that class and that method 6 different times with 6 different pieces of code. And it found, or sorry, it had 20, excuse me, that was different. Sorry, 20 different mutations. And it found 18 tests that failed and 2 that stayed alive. So let's look at then what it outputs for that. Here it's showing the diff of the code that it changed and this is the code that it changed, and then those tests still passed with this code. So here we're seeing an intricate insider Ruby thing where if 2 integers are the same number, they're actually in fact the same object. And so in other words, the equals equals operator is not specific enough for our test. We can use the .equal method, which compares objects. So, okay, that's a fairly simple fix. If we fix that up, we will feel better about our test. All right, now it's still saying it was able to mutate some stuff, and I guess it wants parens around that. That's fine. Oh, thank you. That would be a good help. Cool. One last problem here is that it replaced my entire line of code with just true. So, I mean, it's not wrong. I did not test the false case over here, and so I would need to do that to get 100% coverage here. So let me just quick copy this real quick. This is different going like down to the corner over here. Let's just put another element in there. Excellent. And we reached 100% coverage on that method. Yeah, good stuff. I think it's this button actually up here is the problem. There we go. All right, so out of the Benedict Cumberbatch movies, the 14 of them, and the 14 X-Men movies, which do you think has the higher box office on average? Any votes for Benedict Cumberbatch? Raise your hand. A few. X-Men movies? All right, big time. It was definitely the X-Men movies. This is a fairly close one. But yeah, the X-Men had those are all pretty much all blockbusters, so I think that's reasonable to expect. Let's take a look at the code. I wrote an average method here, and I tested it on an array of numbers on the right. And let's do a mutation test. The first thing it noticed is that I don't need this puts sum here. So I left some debug code in there, so mutation testing caught that, which was really nice of it. Of course, you can test that you are putsing something. You just need to test that system.out will receive something. The other thing it noticed is that I don't need the 2f at the end of my final average calculation here. So here's a case where I can add more tests, right? I'm only really testing over here that I'm getting an integer output. So really, if I just add a quick test here to do, like, say, 3.2, and then up this by 1, then I'll reach 100% coverage on that method. All right, so we've looked at average. Which do you think has the higher median box office? Benedict Cumberbatch. All right, and X-Men. Oof. I'm afraid it was X-Men again, yeah. We should have thought about Benedict Cumberbatch's indie movies and things like that. That's all right, though. Let's look at the code for median. Pretty simple code there. I sort the array and then grab the length of the array, divide by 2, and I'm able to get the median out of this array. So let's do a mutation testing. Here's my test cases over here. I just have one quick test. A few things stick out here. The first is that it was able to pass the tests after removing the dot sort method. So that's because I gave it a pre-sorted array. So that was a good catch by Mutant. Let me just unsort this array, and then we'll, that's it. Yeah, that's it. Then we will come back and try again. Correct, you're right. So the sort is still saying it doesn't matter because the middle value didn't change. That's an excellent catch. Let's change that again. Here you can start to see kind of the game you start to play with it, where it's like the inputs you're giving in your tests just kind of specify a lot of different things. And by having more and more test cases, you do get more coverage and more better. You don't have to deal with that game so much, but it's still always there. All right, here's another case of .fetch. So for array access, you can also use .fetch. You can also use, it shows me a .at down here. .at is more specific for arrays than the bracket operator, because the bracket operator you can use like 0, 1 or 0, 3 to get like a range of elements. But in any case, again, this is what mutation testing does, is it's going to train your brain to just like always write .fetch. When you're getting anything out of an array. Okay, so let's fix our access here. We're going to assume that the array coming in is valid. One last item here. It tried removing array.length and just give me the second element. That's interesting. Third element. I'm confused about why that happened, but so I have to think about that some more. Oh, yes, thank you. Okay, let's just get one more quick test in here, or I can just put it in the same test. All right, good catch, thank you. Nice job. All right, let's take a look at our data then from our competition here. So yeah, I mean, the X-Men movies, as you can see on the right, all pretty much blockbusters, 300 million, 400 million. Deadpool and Wolverine, the latest one, 1.3 billion. Looking at Benedict Cumberbatch movies, 2.7 billion for Avengers Endgame, but there's some other stuff that kind of came in a lot lower. The Mauritanian, 7 million. Power of the Dog was only on Netflix. I tricked you a little bit there. Popular movie, not much box office. And some other new stuff has been relatively successful worldwide, but not to this level, obviously. So, all right, you've seen all those numbers. You've seen all the data and stuff. Which of those box office numbers are valid UPC codes? How many, out of 28 movies, take a guess. 5, 6, 7, 3. I heard 1 out there. 1 is correct. I also tricked you a little bit here, where we had to trim them to 8 digits for a valid UPC. But the first 8 numbers of Deadpool's are valid for that. All right. So how do you calculate? Let's talk about that code really quick. UPCs there's a check digit at the end, so you take the even indices ones, add them together and multiply by 3, and then add the odd indices, and then that should, after you mod by 10, that should equal the final digit. So I feel like I've got everything set here. I've got array.fetch. I've got .equal. I think I'm pretty good for like not having any problems here. Let's see what happens. So it even mutated the array indices I was accessing here. You'll notice in my tests on the right that a lot of these have the same digits in several different places. We could go through a whole song and dance to like make I could keep adding like tests and tests and tests, but I'm not going to do all that math calculation when I have an answer key right beside me here. So anyway, I would copy those in and get 100% mutation testing. So you can see this is kind of the game you start to play to, where it's like, you're adding and adding test cases, and it just keeps reporting back like, hey, you have to tweak this and fix this. But I think you get the idea. So, all right, that wraps up the demo. You can all, release the breath you were holding now. All right, so what are the benefits? Your tests are obviously more complete and your code is covered. I like to think of mutation test coverage not as just code coverage, by like line by line, but also like functionality coverage. You know that you've tested all the functionality that your code is implementing. I think your code really gets more clean and readable and like simpler and more straightforward, just because you have to play this game of making it nice for the mutation tester. You get this improved knowledge of Ruby, like I was teaching some of that stuff now, and I think it's what's particularly cool about mutation testing is that if you have it on your repo, like junior developers who are having to use this technique to get that 100%, they're going to learn stuff, and they're going to learn about how Ruby methods really work and like what outputs they can have. And eventually, you train your mind to code and test without the potential mutations. You're going to start writing code. You're going to start writing .fetch all the time, and have that error pop up if the key isn't there, and that's kind of a good thing. If the key isn't there and you don't expect it to not be there, you want that error. Like I say, you get increased confidence with your unit tests, and your flaky tests are all but eliminated because mutation testing is running your unit tests over and over and over again with a little bit of modified code. But if it can't pass the muster in those mutations, then it certainly isn't going to be a problem in CI. And lastly, I think it really provides a guardrail for AI now. AI code, if you write your tests TDD and you write them by hand and then have AI generate your actual code, I think you'll have a lot of luck with filtering out the extra kind of code that AI sometimes leaves in your code base. But there are some limitations and caveats. So one thing is that, in my experience, my development does get slowed down by playing with those games. And also, sometimes when loading bigger code bases, particularly like Rails stuff, you'll get kind of these low-level errors as it doesn't seem to play well with Zeitwerk or some elements of your RSpec helper or whatever. So that can be frustrating. Also, mutation testing is slow in CI. So The recommended way to run it is on your commit is to only run it on changed code and changed tests, so that you don't have to run the whole mutation suite for mutate your whole code base every time. But even doing that on just changed code can take as longer than your normal test suite. Generally, you want to write your code with fewer normal external dependencies, and your tests too. I mean, your mind kind of gets trained for this, but it does sort of require a little bit of a different paradigm of thinking when you're writing your code. Lastly, the mutant gem can mutate custom DSLs and mixins, but testing those can be kind of confusing based on the way that it mutates the code. It cannot mutate methods that are defined within a closure or an eval yet. So like your metaprogramming can be a little hung up there. The gem itself is a little expensive, $90 per seat per month. That feels expensive to me anyway, but it is free for open source, so that is an option. And then, the point of resource to get support is really the GitHub repo, and that's fine. But there's really not very many online resources for like deeper or those lower level errors that I was talking about. There's not a lot of like help on Stack Overflow, for example, and thus like ChatGPT or whatever isn't going to have a lot of background in it either. I found that AI can do a fairly good job of helping you fix mutations and get in there, but your mileage may vary. So really then the question becomes, should you implement mutation testing in your repo? Well, I find it very difficult to fully integrate it into a large existing Ruby or Rails app. Work computers, right? You could try starting with just like one layer or even just one model and go from there. I think that's a really good approach, because just getting the system set up and getting to like a state where you get that first mutation test run passing is difficult for big apps. And I think like maintaining it as a priority in your code base and as part of your team is as difficult as maintaining anything else, right? You might have flaky front end tests. You might have other policies in your code base you're trying to maintain, and those things, in my experience anyway, can be tough to slip. However, if you work with smaller apps and have like very more isolated things, for example, at Ideon we have our big APIs, but then we also have some smaller UIs that just barely touch those to get some data. Those have been good places to use the mutation testing. And for that point, though, it is excellent for public-facing APIs. You can really weed out a lot of your 500 errors just by having this technique. The company that I used this technique at the most was a API for know your customer and anti-money laundering stuff. That company exited a few years ago to sold to Plaid, and I'm really proud of it. And I especially think that our mutation testing policies there really led to the dependability and helped that sale go through. So I think that was a big plus. Here are my references. There's the main mutants repo. I also referenced another repo I found called crude mutants. I think this works just by eliminating lines of code, so it's kind of like code coverage, code line coverage, but roughly the same thing as mutant, except for not changing your code, just removing lines. You can see the Benedict versus X-Men app here. And I wanted to leave you with one parting thought. Seeing past their differences, humans share a common unbreakable bond. No amount of words of derision, distrust, or disinformation can change the truth that each of us, every gender, every race, every creed, everyone, underneath all the words, we are related. We are all family. This is a quote from Professor X. And I want to stress that I don't mean to put this out there as a like, we should lessen our morals, or we should tolerate that which we don't want to tolerate intolerance. That's absolutely not what I'm saying. Quite the opposite. But I think that even among those that we find a lot of moral disagreement with, on the other side there is a human who cares about something, who is afraid of something, who has wants and needs, just like the rest of us. And I think that a way forward almost certainly involves finding some common ground rather than putting up walls. That's my final thought. I think I have a couple minutes for some questions, if anybody has any. Yes, the question was whether the set of mutations that the gem does is deterministic. Yes, if you look into the gem, there is a set of basically replacements. So it's going to, as I said, it digs into that abstract syntax tree, For example, it finds the bracket operator and says, I can replace with fetch. And if it finds an integer, it's going to try replacing with 0, 1, probably -1, things like that. So yeah. Oh, you mean like if we scan it? The question was, what UPC code does Deadpool pull up if we scan it? That's a good question. It's probably like a banana or something. I don't know. Yes. The question was whether Deadpool is an X-Men. That's for higher powers than me to decide. I believe yes, and I think that would be the consensus among the Marvel writers community. But I'm happy to talk more about that later. One more. The question was whether I've had success using AI to automatically fix mutations. That is a great idea, to sort of run it through AI in sort of a an agentic workflow of, hey, mutation testing this, find the errors and try them and see what happens. I think that for me, I like to an extent, I like that part of the game where I'm able to see what it's thinking and see what, it's telling me I need to replace this, and like, I missed that. So I think I would miss that learning if I did it with an agent, but I could definitely see some power there. All right, thank you again very much.